Now let's look at the ellipse when the equation of an ellipse when it's not centered at the origin, centered at a point hk. Well, so that could be the origin, right, if h was 0 and k was 0, but it expands the possibilities. So, for example, in 25, we have a -3 for the h. So that means that I've taken the ellipse that was centered at the origin and shifted it 3 units to the left. -3, oh, to the right. So that center would be here. So maybe B is going to correspond to 25. I can see that the horizontal distance will be 2, so that's not the right one. So I can see, so the HK is that shift. So I can see here that the 25 is bigger than the 4. So that tells me that this is going to be elongated in the direction of Y, or the vertical. It's going to be a vertical. The major axis will be vertical. So it's either going to be C or D. And then we said that the center is going to be at, the X is going to be 3, and the Y will be a -2. So the center should be at 3, 2. So that's 1, 2, 3, 1, 2. Whoops, that's +2. That looks pretty good. And then for D, 1, 2, 3, that is definitely not the center. So that gives us C to match up with number 25. So follow that similar process for 26, 27, and 28. Look for that center that's been shifted. Remember, it's X minus H and Y minus K. So the opposite of this and this. This one's going to have the center of -3, +2. And the denominator, the square root of the denominator, gives you the size of that axis. I didn't actually do that on 25. I just looked at which one was bigger. The bigger one has the major axis, so that one told me, the fact that 25 is bigger than 4 told me which direction that the ellipse is longer. Okay, so that's that first section. And then moving on to 29 through 38, you have every other odd in this section. So I pulled out some evens to do for practice. So on number 30, we have x plus 1 squared over 36, so it's been shifted. So my center no longer is at 0, 0. My center has been shifted. So remember the formula up here above, been shifted by h. That h must be -1. So it's been shifted left 1, and it's been shifted left down by 2. So there's my center. And then my vertices, under the X, I have a 36. So that means my X, actually, you know what I'm going to do in this one is I'm going to start to graph it, because I think it's sometimes easier to look at graphically. So I'm going to start by plotting my center, -1, -2. -1, -2. There's my center. And then in the X direction, or the horizontal direction, I take the square root of 36. And I go plus or minus from the center. So 6 units to the right. So this is actually x plus 1 squared over 6 squared. So I know that that axis in the X direction and the horizontal direction is going to be 6 units right and 6 units left from the center. So starting at the center, I go 6 units to the right, 1, 2, 3, 4, 5, 6. And I go 6 units left. I go 1, 2, 3, 4. I'll have to estimate there, 5, 6. And those are my vertices in the horizontal direction. So graphically, that's how I do it. Algebraically, I can think of that vertice as, from my original, if I had just done If this was centered at the origin, what we learned in the last lesson was that the x will be the plus or minus 6, and the y would be 0. But we shifted everything. So our center is at -1, -2. I shifted left. The x went left 2, and the y went down 2. So that shifts my vertice as well. So now I get these two vertices. I get -6 minus 1, it gives me -7. And +6 minus 1 gives me 5. And 0 minus 2 gives me -2 for both of these. And you can see graphically that's also what we came up with. So algebraically and graphically, they get the same answer, just a different way to look at it. Okay, now let's do the vertical direction, or the vertical axis. So I have y plus 2 squared, and then I'm going to take the square root of the denominator and square it, so I can see that my axis in that direction goes up and down 3 units. So from the center, my axis goes up 3, 1, 2, 3. So there's a vertice, and down 3, 1, 2, 3. So there's a vertice. So graphically, you can see all 4 vertices now. And again, algebraically, I can see my vertice would have been at, let's see, if this was centered at the origin, my vertices would be, the x would be 0, and the y would be plus or minus 3. But we shifted, so we went left 1 and down 2. So I just took those original vertices and shifted, and I get a -1. I'll do a +3 minus 2 gives me a 1. And -1, and the -3 minus 2 gives me a -5. And you can see on the graph, I also got -1, 1, and -1, -5. So again, same results, algebraically or through the graph. So now it is time to plot my perfect ellipse, because I'm cheating with technology again. There we go. So once I have those 4 vertices, I can just connect the dots in a nice smooth ellipse shape, and there's my ellipse for 30. So that's all well and good as long as you have your equation in standard form. But as you can see with number 34 and example 5, we're not given standard form, we're given general form. So I'd like you to pause this recording, go to your textbook on page 649, and watch the lecture video for example 5. And that walks through how to get from this general form to that standard form, and then we know how to graph once we're in the standard form. We just did it with number 30. So go ahead and watch that, and then come on right back. Okay, so you saw example 5. Now try 34. Follow that same process you saw in the video. See how far you can get. And then go ahead and pause this video while you're doing that. And if you get stuck, or if you just want to check your answer, then go ahead and then come back here and play, and we'll do this one together. Okay, so I'm going to run through 34. If you didn't get a chance to pause and try yourself, please pause now and try it. If you're back, then let's try 34. So I want to group my x's and my y's together. So my x's are 25x squared. Actually, there's no x term, there's just the x squared term. That's already a perfect square. So that one's actually already done for me. So I'll just leave that one alone. And then I'll group my y's. So my y's are the 2y squared and the minus 4y. And then I have that negative 48. I want to move to the other side. So I'll have plus 48. Now, as I said, the 25x squared is already a perfect square, so I'm just going to copy that down without doing anything else to it. But to get the perfect square of this, of the y's, I have to have a leading coefficient of 1. So I need to factor out that 2. So I factor out 2, and I'm left with y squared minus 2y equals 48. I'm going to leave a little space there so I can do my completing the square. Now I can complete the square on the y terms, that parentheses with the y's, by taking half of the middle term. So 2 divided by 2 is 1, and then squaring it. So that's a 1. Whatever I do on the left side of the equation, I got to do on the right. But that 1 is not being added alone, right? It first has to get multiplied with what's outside. So that gives me a plus 2. So that is what goes on the right-hand side. Because on the left side, the effect of that positive 1 is that it's really adding 2 to the left side of the scale. So I have to add 2 to the right side as well. All right, so that gives me 25x squared plus 2, and then I have a perfect square. So y squared minus 2y plus 1, that's a perfect square with a minus sign, which equals 48 plus 2 is 50. All right, so I'm almost there. It's starting to look like it's in standard form. The only thing missing is that I don't have a 1 at the on the right-hand side. I have to end the right-hand side. The constant has to be a 1. So I got to divide everything by 50 to get that 1 on the right-hand side. So 25 divided by 50 gives me 1/2. So that's x over 2. X squared over 2, sorry. And then 2 divided by 50 is 1 over 25. So that's y minus 1 squared over 25. And then 50 divided by 50 is 1. So that leaves me with my final standard equation. And then we talked about how to graph that one already. We looked at, in the x direction, I have the square root of 2. So that's about 1.3. Oops, I forgot about the center. Right, we're not centered at the origin here. So let's do the center first. I did that in purple. So my center, my x didn't shift, but my y shifted up 1 unit. So my center's at 0, 1. And then so I'll plot that. So 0, 1. And then in the x direction, I take the square root of whatever's under the x squared. So that's about square root of 2, that's about 1.3. And in the x direction, I go right 1.3 and left 1.3. Or 1.4, sorry. And so those vertices in the x direction are plus and minus radical 2. Whoops. And the y is 1 for both of those. And in the y direction, I take the square root of the denominator under the y squared term, and that's the 25. So that means that's going to be up 5, down 5. So plus or minus 5. So from the center, I go up 5, 1, 2, 3, 4, 5, and down 5. 1, 2, 3, 4, 5. And I find the vertices are at 0, 6, and 0, -4. And then my last step is drawing in that ellipse. And there is 34 graphed. All right, so hopefully you enjoyed those graphs, and you can take it from here on 29 through 37, every other odd.